which this one is, x to the first power. If it's linear, then I can use synthetic division. That's the easier one. If, look at this guy, look at the divisor here. Is that linear? What is it? It's got the squared thingy, which we call that quadratic. It's quadratic. So I can't use synthetic division. I have to use long division on that. Old school long division. All right. There's some rules that apply. So let's do the yucky one first. Okay. So the divisor is what goes on the outside. Now, when you write it out, it needs to go down in all the powers of x. So this one just goes x squared to no x's. Notice that, right? So what I want to do to make my life easier is put a placeholder in there for the x to the first power. Doesn't change the value, but will help everything line up under my division bar. Plus 1. All right, then I do my little division bar. And I also want to make sure what I'm dividing into goes down in correct exponent order. All right? This one should be at 27x squared, by the way. So it is in order the way they gave it to me, but beware, sometimes it's not, and you got to put it in order for it to work. Okay. So far, so good? All right, then it becomes just like what you did in 4th grade when you learned long division. So you look at this first term, x to the 4th, and you ask yourself, what do I need to multiply x squared by to get x to the 4th?
X squared.
I need another x squared. So I'm going to do x squared right up here. Set it right on top. And then I'm going to distribute x squared to every term on the outside, right? The divisor. So x squared times x squared gives me x to the 4th. X squared times x, 0x, is 0x to the 3rd. And then plus 1x squared. Then, just like you did before, you're going to have to change all these signs to be opposite what they were. So now they're all negative. And the reason is you need this first term to turn into 0.
Only that term?
Only that term.
Okay.
And then you combine the rest. So 3x cubed minus 0 is still 3x cubed, right? Mm-hmm. And then this one, when I combine them, I get negative 28x squared, and I bring down the next term plus 3x. All right? Then I start the process all over. Okay, I have 3x to the 3rd. What do I need to multiply x squared by to get 3x to the 3rd?
3x.
A positive 3 and an x. So it'd be a plus 3x. Then I'm going to distribute just like we did before. 3x times x squared gives me 3x to the 3rd. 3 times 0 is still 0, but then there's my x squared term to keep everything lining up correctly. Plus 3x. Then what do I have to do from here?
Change signs.
Change your signs, exactly. So I'm going to change all my signs to be opposite. And does my first term disappear? Yes, that's what I wanted. And then I'm combining like terms. So now I have negative 28x squared plus 0x, huh? Yeah. And then bring down the next term, minus 28.
So do we have to put the 0 so then it just cancel out?
You don't have to, but it keeps everything in line.
Okay.
Keeps you from getting things off.
Okay.
It's just a placeholder, helps line everything up. All right, now we're going right back to where we were. What do I need to multiply x squared by to get negative 28x squared?
Negative 28.
Yep, just negative 28. So when I do that, oops, minus still 0x minus 28. Then what?
Flip the sign.
Change my signs. Okay, first term turns into 0. That is just 0, and this is 0. So this is remainder of 0. Yay, we like it when it works like that, right? Yes, indeed. All right, now Notice the instructions. This is divide and factor the polynomial completely. So when I'm done, I know I'm done when I can factor out my polynomial, the original, this guy, all the way out. So how many, looking at that, how many solutions will it have?
4.
4. How'd you get that? You're right.
Because of the exponent number of
The highest exponent's of 4, so it's going to have 4 solutions, right? Okay, well notice that this one right here accounts for 2 of them, doesn't it? Because it's squared. That means there's 2 more left in this one. So, I'm going to take what I have. So I know right now that that polynomial, x squared plus 1, I divided by that, and I got that times x squared plus 3x minus 28, which is what I got up here. So far, so good? Now, I want to keep factoring. Can I factor this guy? Will that factor? Into what? 2 numbers will multiply to negative 28, but add up to positive 3. Plus 7, x minus 4, right? So, this is my final answer, because it says it wants it wanted to be factored completely. You do not have to solve it further, you're just leaving it in factored form. You tracking with me? All right. Now, just for example's sake, let's see if you remember. Let's pretend like this didn't come out nice and pretty and as 0. Let's say I ended up with like a 17 there. What would I do with that?
Do you put that over x squared plus 1?
Yeah, it would be a remainder that I would ultimately write as plus 17 over the divisor x squared plus 1. Now that's just so you know what to do when you run across one that does that. But if I'm asking you to factor it completely, it shouldn't have a remainder. Okay?
Okay.
That's just food for thought. You should have seen that in the video. I just want to bring it up just in case. Maybe I should just do it backwards. Oops. All right, now let's try a synthetic division one. These go much faster. But again, everything has to stay in exponent order. All right, and my little divisor bar looks like that now. So I'm going to line up my coefficients in descending exponent order. So I have a 1, negative 7, 27, 72. And then what I put over here in this box is what I get is if I take that divisor, x minus 2, and I solved it. I would get what? A positive 2, right? So I'm going to put a positive 2 right there. Now, synthetic division. It's a lot simpler looking than the other, isn't it? So, first thing I do is bring that first number straight down. 1. And then we multiply. 1 times 2 gives me 2. And then we combine. Negative 7 plus 2 is
Negative 5.
negative 5 times 2 is
Negative 2.
26 minus 10 is
16.
times 2
32.
is 32.
And that's 40. So 40 is the remaining.
What?
Wouldn't
How'd you get 40, bro?
aren't you supposed to subtract that?
Mm-mm.
Or we put that
Positive
under-
16. Right?
104.
What did I do wrong? Huh?
I was saying it's what the remainder is 104.
Yeah, the remainder is 104. So this one doesn't factor much. But the way I would write my answer is I put this back in an equation form. Okay? So if this started at x to the third and I divided an x out, this is now just 1x squared minus 5x plus 16 plus, here's my remainder, 104 over x minus 2. Okay? So to factor completely, I have this times x minus 2, which is what we originally divided by. Okay? Got it?
Got it.
Can we handle it? So this is how we're going to handle the equations with bigger powers than like a 2 or a 3. We just divide it by another polynomial, get those powers down until we can factor, use quadratic formula, or something of that nature. Okay? So, want you to work on